Looking at the stock solution in the volumetric flask, looking at it from eye level, we can see that the meniscus is not above the mark in the volumetric flask.
Alright, ready to hold it again? So these are all of our dilutions from our stock solution, including our blank solution that's just 5 milliliters of ammonia diluted with water.
Alright, so we're going to take all of our solutions, including the blank solution, and put it into the cuvette with a little pipette. As you can see, there's a line on the cuvette, and we're going to fill it up to where the meniscus hits just under the line because we don't want the machine to take up too much of the product.
We filled the cuvette with a stock solution and we made sure that the meniscus was below the line.
We will now repeat this with all of the other cuvettes.
We have now filled up all the cuvettes with the solutions and we're going to take it to the spectrophotometer.
So right now we are writing down the data from our stock solution, and we're going to take the average of these numbers. So RTA already used our blank solution as an example, so that's not shown in the video. However, I will show where we zeroed it out. So not seen in our videos because our TA did it for us is a little 0 button right there, and that's how you zero it out. And then we're set at 560, and that's how we've got our data after we've scanned multiple times. Right now we're on simple reads, but where she used our sample as an example for our blank solution, we were on an app called Scan app. Go.
So using the little triangle right here, we need to make sure that both sides are clean using a lab tissue. So when I put it in to the spectrophotometer, that it can be read correctly.
Now that our first dilution is in the machine, we're going to click read 3 times. And take the average of those 3.
Now we're going to repeat the same process that we did with the first dilution with the next 2 dilutions in the spectrophotometer.
So we repeated the same steps, and here is all of our data. You can see that 7 through 9 is our sample number 2, and 10 through 12 is our sample number 3.
So now, being careful, I'm going to carefully remove the cuvette from the spectrophotometer.
So our lab bench is clean. We're about to turn in our paper.
So this is the equation for absorbency, which consists of absorptivity, concentration, and Lambert's max. Lambert's law is just a constant of 1 inch. So the relationship between absorbency and concentration, as you can see here, is that the absorbency ultimately depends on the concentration of the solution. So the reason why you scan across all the different wavelengths is because you want to find the wavelength that best portrays the relationship between absorbency and concentration, and you set the reading to 560 nanometers because it's the lambda max of the wavelength.
Thanks for watching our video.